Okay, this video is a continuation of the work we started in part 1. So in part 1 we showed how to integrate the first example. This time we're going to go on to the second example. We've got the integral of x squared minus 12 divided by x cubed minus 2x squared minus x. So as before, we're just going to extract the integrand and then factorize the denominator and then proceed from there. So we've got integral of x squared minus 12. The denominator is x cubed minus 2x squared minus x, 8x. So we're just going to work with the integrand here. So x cubed minus 2x squared minus 8x. Our first task is to factorize this. We notice that all the terms in the denominator involve x. So first thing we're going to do is to factor out x. So it's going to be x squared minus 2x minus 8. So this is now a quadratic, and we already mentioned in part 1 that you want to freshen up your skills of factorizing quadratics for these type of problems. So this one is going to factor out 2 x minus 4 into x plus 2. And so we are going to write this out going to resolve it into, or decompose it into partial fractions. We're going to have 3 partial fractions because we've got 3 linear distinct factors. So we're going to have ax plus b over x minus 4 plus c over x plus 2, where a, b, and c are numbers we need to find. So then, as we did in a, we're going to clear fractions here by multiplying everything by this term here. So if we do that, the left hand side is just going to give us the numerator. The first term here, if we multiply by this, the x will cancel out. So we're going to have a into x minus 4 times x plus 2. When we multiply the middle term, the x minus 4 is going to cancel out. So we're just going to have here bx into x plus 2. And then lastly, multiply the last term, the x plus 2 is going to cancel out. So we're going to have cx into x minus 4. And then we are going to substitute the roots of this denominator here. There's going to be 3 of them. For this one, x is 0. For this one, corresponding root is x equals to 4. And then for this one, the corresponding root is x equals to negative 2. If we plug in x equals to 0, the left-hand side here becomes negative 12. This one is going to be negative 4 times 2, going to be negative 8a. If x is 0, this vanishes and that vanishes as well. So this tells us that a is going to be 12 over 8. So a is going to be 3 over 2. Then next we plug in x equals to positive 4. X is positive 4. This left hand side is going to be 16 minus 12. It's going to be 4. The first term is going to be 0 because we're going to have 4 minus 4 here. This one is going to be 4 times 6. So we're going to have 24b. The last term is going to be 0 again. So this tells us that b is going to be 1 over 6 from 4 over 24. Then lastly, we're going to substitute x is negative 2. The left hand side is going to be 4 minus 12. So that's going to give us negative 8. And then only the last term is going to survive, because that term becomes 0 and that term becomes 0. This is going to be negative 2 times negative 6, which is going to be negative 12. So this is going to tell us that C is actually 2 over 3. Okay, just make sure that there are no mistakes here. Yeah, there is a mistake actually. So from here we're going to have negative 2 times negative 6, so that's going to be positive 12. So this is going to be negative 2/3. All right, so what's going to happen then is we are going to plug this in here. We're going to plug this in there, and we're going to plug negative 2/3 in there. So our integral, so if we call this I, so our integral is going to be integral of a is 3/2, so 3 over 2 divided by x, plus 1 over 6, which is b, divided by x minus 4, and then minus 2/3 divided by x plus 2 dx. Again, if we write this as separate integrals, it's going to be 3/2 into the integral of dx on x. Then the second one is going to be 1 over 6 integral of dx on x minus 4. This one is going to be 2/3 integral of dx on x plus 2. Now in all these cases the coefficient of x is 1. So if you want to recall, we had this formula here that we use. So always divide by the coefficient of x. So in all these cases that is 1. So this is just going to be ln of magnitude of x plus 1 over 6 ln magnitude of x minus 4 minus 2/3 ln of magnitude of x plus 2, and then this is going to be plus c. All right, so at this point we're going to take a breather and then give you an opportunity to have a go at the last two examples. You want to have a go at C and D. So what you can do is pause the video, have a go at these two, and then when you continue the video, then you will find our solutions. All right, we're now going to scroll down to our solutions for C and D. By the way, do not forget to hit the subscribe button, and if you've got any questions on all the stuff we are doing, please feel free to post them on the comment section. Okay, so for part C, so we're going to take out the x plus 3 over 2x squared plus x. Factorizing this gives us x into 2x plus 1. So these are going to be our two partial fractions. So then clearing out the fractions, I'm sure you're going to have noticed by now that if you have got just two fractions here, then what happens here is just some cross multiplication action. So this is going to multiply a, and that's going to multiply the b. And then our roots are 0 and minus half. The 0 gives us a is 3, the minus half gives us minus 5. And so that means our expression is going to be 3 on x minus 5 on 2x plus 1. This integrates to ln x. This one is going to integrate to ln 2x plus 1 divided by 2, because we have got a coefficient of 2 on the x. Alright, and so that's going to be the final expression. For this one, the denominator is a cubic, so we need something a bit more than just techniques of factorizing quadratics. In particular, we are going to use something called the rational root theorem here. That theorem says the roots of x cubed minus 7x minus 6 are just factors of 6. So that means we're talking plus minus 1, plus minus 2, plus minus 3, and plus or minus 6. So if you try these ones and substitute them in here by the remainder theorem, if any one of them is a root, then plugging in here is going to give us 0. If you plug in 1, it gives us 12, so 1 is definitely not a root. If you plug in -1, we find that it gives us 0, so x is -1 is a root, and x plus 1 is a factor. So again, if you're not up to speed with this, check our videos on the rational root theorem. Okay, and so if x plus 1 is a factor, it means we can divide this expression by x plus 1, and the remainder is going to be 0. So if you use synthetic division here, again, you can check our video on synthetic division. Then we find that the quotient is going to be x squared minus x minus 6. This is now a quadratic, which we can factorize. And so 1 over x cubed minus 7x minus 6 can be written like this. And then decomposing this into partial fractions, these are going to be the three partial fractions we have. Clearing the fractions gives us this setup here. And then so we're going to plug in the roots. We've got -1, -2, and 3. So those ones give us respectively a is -1/4, b is -1/5, c is 1 over 20. And so our expression is going to look like this in terms of the partial fractions, and then that integrates to give those terms there. All right, thank you for watching.